Hi, welcome to this session for School of Ops on capacity. So to start off, let's talk about a little bit about what's important when we're talking about capacity. So a couple of the key questions that I will kind of walk through during the session is a couple of these questions here. So do I have enough capacity to run my workloads? When do I need to buy more capacity? Can I reclaim resources so I don't need to add capacity? Various questions like that related to capacity of your environment. So with that, we'll just kind of jump right into it. And first off, vRealize operations is one of the best tools for managing the capacity for your VMware clouds. So with that, kind of dive into some of the details for how capacity works and what you get out of it in vRealize operations. So it lets you do some things like predicting when you're going to run out of capacity. It supports basically any vSphere-based clouds. You know how much capacity you have left, and then there's a lot of things that you can tweak and tune to make the capacity projections more meaningful for the particular circumstance. So you can see things like our projections of what our utilization is going to look like into the future, what we think is going to look like, and then get recommendations on things we can do, whether it's add capacity, reclaim resources, or migrate workloads, things like that. And then the last thing here is for talking about reclaiming capacity to save both capacity and save money. So there's quite a few different ways of reclaiming capacity. So you can look for powered off virtual machines, auto virtual machines, snapshots, and orphan disks. So the system automatically looks at all of those and then identifies those and tells you where which virtual machines you can go and do some reclamation on. So just since we're getting into some of the reclamation piece, I just want to mention the idle virtual machines because this is a relatively new change as of 8.6. So you can actually go in and modify the thresholds for what defines an idle virtual machine. So now, not only can you say that the virtual machine has to be idle for a certain number of days, you can also set thresholds on things like the CPU utilization and the percentage of time that the virtual machine needs to be below that threshold. And then there's also options here now to exclude the virtual machines, like newly provisioned virtual machines. So basically to give users some time to go and start using the virtual machines before you track it as being idle. So that's one of the new capabilities. And the next piece here is actually talking about our what if analysis, what if planning. So this is where you can go and model various scenarios and say, what does it look like if I add virtual machines or add hosts, remove hosts? What if I migrate to the cloud? Things like that. So it's going and doing all that kind of analysis to see what it would look like if I do certain scenarios. So now we'll kind of dive in and talk a little bit about how some of this stuff works and how we get to some of these capabilities. So to start off, we have this forward-looking analytics engine in vRealize operations that actually goes and is responsible for doing all of these projections. So it takes this historical utilization of the virtual machine. So every 5 minutes, the new data point comes in, and then the projections get updated to figure out what the system thinks that this workload will do into the future. So this is something we call it real time because it's basically redoes the analytics every time a new data point comes in. So every 5 minutes, and it adapts and learns to the behavior of the workloads over time. There's some other capabilities in here which I'll kind of talk a little bit more about later, but there's exponential decay, so that kind of gives more weight to more recent changes in utilization. And then calendar awareness, so looking for periodicity, things that happen on certain intervals. So these can be certain days of the month or certain times of day, things like that. So kind of want to step back and kind of level set on some of the definitions and terms that go into these projections to kind of help understand, what the system is actually telling you. So I've created this little infographic here and kind of run through kind of quickly and kind of define these terms. So it'll help make sense when you're looking at the UI what these various pieces mean. So total capacity, that's all the capacity for in this case, we're talking like a cluster. So it's the total capacity of a cluster itself. HA, so that is the capacity reserved for admission control. So this is what you set in vCenter to reserve for HA. Buffer is a setting that you set in vRealize operations. So this is basically a way of reserving additional capacity above and beyond what you set for HA. So this could be for things like, when you have a stretch site or you just want to, or maybe you don't use admission control. This gives you another way of reserving capacity. So we have, the next one is usable capacity after HA and buffer. So the name's pretty descriptive there. So basically, you take your total capacity and you remove HA and buffer. And then that is basically what you have left. And that's where the workloads can run. So, like I said, it takes away all the resources needed for everything to manage the cluster. And then overhead. So this is the resources needed to by the hypervisor to run the workloads. So this is additional memory and CPU cycles that are needed to run virtual machines. We have usage or utilization. So this is the amount of basically the amount of resources that the virtual machine is actually consuming. So look at CPU memory usage. That's basically what the virtual machine is actually doing. And then demand is what the usage would have been if there was no contention. So you look at if there was co-stop or ready or contention for hyperthreading, et cetera. Those get included in there and says this is what the workload would have used if there was no contention. And then contention, defining that is basically the resources that the virtual machine would have used, but basically didn't get access to. So again, like I said, this is like CPU ready, co-stop. This is also things like VM swap. That's basically the resources the virtual machine wanted but couldn't get. So that kind of covers the main terminology that goes into most of the capacity piece. Now I'll kind of talk about a couple of different ways of looking at capacity. So the first way is looking at it from a demand perspective. So vRealize operations always looks at it capacity from a demand perspective. So this is useful because it's based on demand. You're actually looking at what the virtual machines are actually consuming on the host or cluster. So basically everything is based on performance and utilization because it's based on demand. So it's really important, that you know exactly what's going on because this is what the virtual machines are actually consuming. On the other hand, we have allocation. So allocation is when you look at basically the provisioned resources for a virtual machine. So a virtual machine has 2 vCPUs, that's allocation. If it's using 100 megahertz of CPU, that's demand. So the units are different. It's easier to understand the difference when you think of it from a CPU perspective, because you're talking 2 completely different things. So from an allocation perspective, it can be useful for procurement planning or environments where when you have like no overcommit. So it's very strict kind of environment where from an allocation perspective, you don't care about the utilization. So I don't care if the virtual machines are running 100% or if they're running at 0. The actual utilization of the virtual machines don't matter. It's what's provisioned to the virtual machines that is important. And the vRealize operations actually goes through and can look at both. So it looks at the most constrained of demand or allocation, and then kind of tells you, which one is the most constrained, so when you're running out of capacity. So even though allocation doesn't look at utilization, demand does. So it actually looks at it from both perspectives. But like I say, allocation is an optional setting, so it's something you would have to go and enable. It is not enabled by default. So next thing I want to talk a little bit about the engine itself. Basically what comes into the engine is essentially like your utilization or demand, and then the usable capacity of the object you're looking at. And then from the other side comes out, you get some metrics like time remaining, capacity remaining, VMs remaining, VM shortfall, recommended size, and recommended total capacity. So you feed all that in, and you get this additional data coming out of it. And like I said before, this happens every 5 minutes. So whenever a new data point comes in, all these calculations are redone and comes up with new projections. These projections coming out of the system go out a year into the future. And they do look at patterns and usage, and it tries to cover at least 90% of the future. So when you look at the projection in the future, it actually tries to fit at least 90% of that projection in its projection. So, and the last thing here is usable capacity. Is basically, it would be the same as total capacity for objects that don't have an HA concept. So things like virtual machines, there's really no difference between usable capacity and total capacity. They essentially are the same thing because there's no such thing as HA for just a virtual machine itself. So that's where, like a cluster would have HA, but a VM doesn't. So with that, I kind of dive into some of the capabilities to tweak the projections from the system to help get the more meaningful and useful projections. So you have basically two different options for your time remaining risk level. So you can either set it to conservative or aggressive. So conservative, like the name implies, is conservative. So it actually looks at basically the upper bound of the projection. So whenever you create this projection range, it looks at the upper bound of that to say, this is my conservative projection based on looking at the upper bound of the range. And then aggressive looks at the mean, so that basically the average between the upper and lower bounds. It basically follows the average line for those. So it's definitely more conservative. More aggressive on the aggressive side. So the aggressive might be more applicable for like dev test workloads, where you can push the workloads a lot more closer to the edge. And conservative would be more for like production style workloads. So a new capability that was added in 8.6 is the ability to tell it to focus on peaks. So now this is basically not just looking at all the utilization. It basically gives more weight to the peaks. So when you have workloads that are very that have a lot of peaks, but the kind of short peaks that don't last very long, you can actually enable this peak focused option to basically influence it to basically shift the workloads higher to cover more of those peaks. So you can see from the chart here, you can see the top one here. It is basically showing utilization is going to be lower, but when you enable the peak focused, it actually looks at the utilization, and that projection has shifted up a lot higher. So this peak focused is independent of whether you set conservative or aggressive. You can set conservative or aggressive, and then focus on peak can be enabled for either mode. So just keep that in mind when you're looking at that. And the key point here is if you have a lot of workloads with a lot of little peaks, where this could be advantageous to enable. Okay, so now I mentioned several different terms from the capacity engine that it output. So now I want to kind of go through and define what those terms are and basically how they come to play. So I've got several charts here, which I'll run through. The first one is time remaining, and this is looking at it when you set to conservative. So basically what it's doing is it's looking at the projection here, and it's looking at the upper bound, and looking at when that upper bound of the projection crosses the usable capacity line. So you see where this vertical red dashed line, That's where the upper bound of the projection crosses the usable capacity line. So the amount of time between now and that dashed line is my time remaining. So that can be basically anywhere from 0 up to say greater than a year. So it's important to look at that intersection and know when that happens. And then everything here on the left is my historical utilization. And then everything on the right is the projection that we're looking at. So with that, we'll kind of switch over and show the aggressive. So it should look very similar. But we see now we have this dashed line in the middle, which is the mean between the upper and lower bounds. And now we're looking at where that mean line intersects with my usable capacity. And then that's where my time remaining comes from. So you see we've only shifted from looking at the upper bound to the mean. So the next one is talking about capacity remaining. So capacity remaining is instead of looking at just right now, the system actually does a small projection 3 days in the future, and this helps kind of smooth out some of the big fluctuations that can happen. Kind of helps makes it where it doesn't jump up and down quite so much because it's based on that projection 3 days in the future. But this can trip up some people because they don't realize that it is based on a projection. There's some assumptions that it's right now, but the important part here is this is a projection just 3 days into the future. So it basically takes that projection, looks out 3 days in the future, and then the difference between the upper bound and my usable capacity line is my capacity remaining. So this is looking at it from a conservative perspective. So that's why I'm looking at the upper bound. And then the next one here is aggressive. So now I'm basically going from the mean 3 days in the future, looking at the mean of the projection between there and the usable capacity line. So that gives me my capacity remaining. Hopefully that makes sense. And then the key part for capacity remaining is to remember it's a 3-day projection. So there's a couple of settings that I want to talk about next. So we have this, what we call time remaining score threshold. And this is an important setting for basically telling you when you're going to be running out of capacity and kind of setting your criticality of those timings. But it's also useful for right sizing of virtual machines and clusters and et cetera. So it's important to know what these are set to and how this affects the capacity projections from the system. So there's basically 2 different defaults worth pointing out. So the first one is the cluster default. So the defaults are 120 days for yellow, where that's the warning threshold, and 90 days for red, which is the critical threshold. So you would want to adjust these to basically give you enough warning that you can go and buy new hardware. So you can get the alert soon enough that you can go and buy hardware, get it online before you are out of capacity. So that's important to tweak it from that perspective. And then the other one is for virtual machines. So the default for virtual machines is 30 days for yellow or warning threshold, and 10 days for red or critical threshold. So this one is useful for right sizing, which I will show in a minute where that comes into play. So recommended size is the name of the metric that is powering the right sizing recommendations from vRealize operations. So the important part here when looking at the recommended size, whether it's for a cluster or a virtual machine, is basically the system takes the projection. So this is conservative. So we're looking at the upper bound projection. And then it projects that out into the future. So it uses that time remaining score threshold and adds 30 days to it. So for example, a virtual machine, the threshold for was set to 30 days by default. So I add another 30 days on there. So now this says, basically it's going to right size my virtual machine based on the projection 60 days into the future. So I will basically go out here 60 days into the future. So my time remaining score plus 30 days, that gives me where I want to look. And then I go up and figure out anywhere between now and that point in the future, what is the highest utilization for that virtual machine. So we can see here, this particular example has it happening at the end of that time range. It doesn't have to be at the end, but this one has it at the end. So that basically would be my recommended size. So I've projected out the utilization to the future, and that's where where it intersects, and that is what is recommended for the virtual machine. So the key point here is this is based on the projection. So it's not only looking at the historical utilization, it's projecting it into the future. So what we're actually recommending can be much more proactive, because it's based on the growth rates and trends and stuff that we can see in the workloads, and we have a good idea of what potentially could happen into the future for these virtual machines. So the next one here is looking at from aggressive. So it's just like the other one. Instead, we're looking at the mean. So the mean, we go out for the time remaining score plus 30 days, look at where that intersects with the mean, and then that is our recommended size for the virtual machine. So, and again, that could be above what the usable capacity is for the virtual machine now, or it can be below if the virtual machine is undersized or oversized. So where that happens to fall is important to basically to say whether the virtual machine is oversized or undersized. And then the other part I wanted just to mention is, like, I tried to say it before, but the point is, when we're looking at this time range, we don't just look at the end, we look at anywhere through that time range. So, we could have a virtual machine where the workload is projected to decrease. So the highest utilization might be at the beginning of the window, might be right now. So when we come up with these recommendations, we're not just only looking at the end of that time range, we're actually looking at the entire time range. So whatever the peak is throughout that entire time range, that's where we concentrate. So recommended total capacity. So now this one only applies to objects that have HA or buffers. So this would be for like a cluster. So the important part here is, it functions basically the exact same thing as recommended size. So you can see I have it on here as the recommended size, but then we add on HA and buffer based on what's configured for the cluster. So we add those resources back on, and then that gives us our recommended total capacity. So this is the recommended capacity of a cluster based on the projected utilization plus HA and buffer. So hopefully that makes sense. So this can be used to basically right size a cluster itself and to make sure it has enough HA and buffer to run the workloads that are in the cluster. And then aggressive, again, it's the same, but we're looking at the mean instead of the upper bound. And then we add on HA and buffer on top of that as well. Hopefully that's pretty straightforward. So I have a chart here that kind of has everything highlighted. So the spots on the charts where all of these metrics come from. So this is the conservative version, and then here's the aggressive version. So you can see how they differ, and it's basically looking at where on this projection. Okay, so now let's switch in and talk a little bit more details about some additional concepts that are useful to understand. So I know I would just talk about the oversized and undersized virtual machines. For this is the right sizing recommendations. So a couple things you need to know about the recommended size. So the system does do some artificial caps on the recommendation. So if a virtual machine is oversized, the recommendation will be capped at 50% of what's currently allocated to the virtual machines. So you can see the example here. It says if the virtual machine has 8 vCPUs and never use more than 10%. So VREPS would not recommend to take away 7 virtual CPUs. The cap would come into play and said only reclaim 4 vCPUs. And this is done to make it to be more conservative, and you can gradually step down the allocation of resources to the virtual machines. So you eventually come to the right size of the virtual machines over time. So it kind of helps avoid creating these really big drastic changes that could come into play for VMs that are very oversized or very oversized. And then the same for undersized virtual machines. So there's a cap for those as well. So a recommendation would never be more than 100% of what's currently allocated to the virtual machine. So if you have a VM with 4 vCPUs, you won't see a recommendation above 8 CPUs. So basically, you would not see, it would not tell you to add more than 8 CPUs or more than 4 CPUs to a 4 vCPU VM. Again, this will help you, gradually get up to the right size without making really large changes. Okay, so the other thing that comes up a lot is people want to know how much data is used in these projections. How far back does it look? And then how much data is actually gone into some of these projections. So the important part to look at is you can actually go in the system and look for this vertical line on the left called projection calculation start point. You may have to change your time ranges to be able to get look that far in the past to see it. But the point is, when you go back and you can see that vertical line, that's basically saying that's how much data is going into the projections for the workloads for the virtual machine or the clusters. So that answers how much data. And basically, the system uses all the data that it has. There are some caveats dealing with some upgrades from older versions, but essentially, barring any upgrade caveats, essentially it's using all of the data. But we have this thing called exponential decay, which basically will tell the system to give higher weight to more recent utilization. So a virtual machine's workload can change over time, so you don't want to always assume what happened a year ago will be the same thing or have the same amount of weight to what's happening to the virtual machine right now. So that's where it's important. As the workload changes, it can adapt to those changes more quickly because of this exponential decay. And then the last point here on the slide is talking about the data retention. So you don't have to retain all of the data in the system for the data to have an impact on the projections. So you can set, like if you have your data set to keep only 3 months, the projection can still be based on data that's a year in the past. So even though it's been purged out of the system, the impact of that utilization still has an impact on the projections. Hopefully that makes sense. It's the way the algorithm works behind the scenes. It actually can be influenced by that data, even though it's not in the system anymore. So what happens if if the projection looks off? If something doesn't look right, it could have been that there was a drastic change in the environment. Maybe you retired an old storage array that just took away a lot of storage capacity, or you had a really big influx of new workloads. Maybe it was a migration to a new cluster. There's going to be different changes that can cause the utilization to basically change more than it normally would. Sometimes you would want to go in and just reset the capacity projections to basically ignore that time range from when that drastic change happened. So that's where this reset capacity projection option came in. So we can actually go in to, say, a cluster and go and reset the capacity calculations. You pick a date that you want to reset it to, and then the system will start basically doing the projections and ignoring anything older than that time range, that date that you had specified. So this is important. Like I said, when you have those really big changes, you can actually adapt to those changes, make it adapt more quickly. So the next thing is talking about peaks. So there's a lot of different kind of peaks, and there's a lot of questions that come into, how are peaks handled by the system? How does it affect my projections? So I've kind of classified it into 3 different kind of peaks. So there's one that I'm calling a momentary peak. So this is like a short-lived peak. It looks like it's one-off. It looks like whatever happened, it just happened that once, and it never happened again. So those kind of peaks, which we call momentary peaks, in general should be ignored because when you look at the historical utilization, it doesn't look like that's important. So that kind of peak in general is ignored because it doesn't look important. The next one is a sustained peak. So this is a peak that lasts for a longer period of time. And the thing with those is the longer the peak, the taller the peak, the more impact it could have on that projection. So you can see here in this diagram, kind of introducing some uncertainty, saying, well, it might go up again. So that's where my upper bound has been made a little larger, is because it thinks that peak might come back because it was big enough. And then the last one is periodic peaks. So these are peaks that have patterns to them. So these can be things like once an hour, daily, weekly, monthly. It can be specific days of the month. There's a lot of different different patterns that could be going, and you can even have multiple patterns going on at the same time. So you can have an hourly pattern with a monthly pattern. And the system can go and actually detect those different periodicities and then use those periodicities in the projections. So if you see in the projections, it actually has these lines that go up and down, up and down, up and down. That's because it's detected that periodicity and then it's projected that periodicity out into the future. So in general, that's the three main types of peaks that we deal with. Hopefully that helps you understand how they get factored in. So a couple of things I want to talk about from the UI perspective. So when you're looking at the capacity tab, this happens to be a cluster itself. The main things you want to look at is time remaining. So time remaining is looking at, like I showed on the diagram before, this is the time before you run out of capacity. But what the system does is it takes and looks at all of the different models that are enabled. So in this particular screenshot, I have CPU allocation, memory allocation, and disk space allocation all enabled. So it's looking at basically all 6 different ways. So allocation and demand across CPU, memory, and disk space, and then finding the most constrained resource of those. So you can see this one is memory allocation. I've got 48 days. So because that is the most constrained resource, that is where my time remaining comes from. So hopefully that makes sense. It's, like I said, it's looking at the most constrained resource, and then that is the time remaining for the object itself. And then the next thing you can look at on the capacity tab is what we call capacity remaining. And again, this is looking at a cluster. So you can see here, the system is telling me how many VMs will fit in my cluster. So this is looking at the capacity remaining. And then it's saying within that capacity remaining, how many VMs can I fit in that capacity remaining? And then that's where it's coming up with that projection. So the capacity remaining, the virtual machines remaining can be based on, by default, it's based on the average VM profile. So it looks at the average size and utilization of the virtual machine in the cluster. But you can go and actually define custom profiles. And then the system can figure out the VMs remaining based on any custom profiles that you define as well. One thing I do want to point out here is the little table that's on the bottom of the capacity remaining page. This is looking at basically your capacity remaining across all of the different capacity models that are enabled. And from there, you can actually go and kind of dig in to see what's going on. The key point here is these numbers are based on a projection 3 days in the future. So you remember when I was talking about capacity remaining, is that 3-day projection. So when you're looking at this table, this is also a 3-day projection. So you just need to be careful, when you're trying to compare the numbers. Just remember, these are projected numbers. It's easy to get you tripped up on those. And then the other thing I want to point out is if you have a cluster that's basically out of capacity, so you've gone beyond what the cluster can handle, the system will go and actually identify the shortfall for the virtual machine. So like this particular cluster, I have no VMs remaining, but I've gone beyond by 2 virtual machines. So I actually have a shortfall of capacity that's 2 virtual machines. So it's important, and the reason this is separate is so when you can do roll-ups to a higher level. So like if you want to look at across your entire environment, you can sum up the shortfall, and you can sum up the virtual machine remaining, and then you can have those two individual numbers, and they kind of tell you the picture of what's going on. So, and I mentioned the custom profiles. So this is the profiles that you can define, and this is basically how the system will calculate the VMs remaining and the VM shortfall. You can go in and define your virtual machines. Like if you have a small, medium, large T-shirt size, you can define those. Or if you have specific use case, like maybe a cluster, a SQL server or something, you can do those kind of definitions in here as well. And you can define them both on demand or allocation based. You just need to make sure that if your cluster is running in demand mode, you define the demand numbers on your profile. Or if you're running in allocation model, you can define both allocation or demand.